This is city science class, and we typically do something different for every class. And I think you'll hear a little bit along the way about some of the prior classes. This class, we are focusing on the research that goes on in the city science group, which is right on the other side of this wall. So we've been engaged in this research for many years. We come at it with the realization that, that most of the action is in cities. I mean, that's where the grand challenges that we're facing will probably find solutions. Climate change, public health, equity, et cetera, jobs for a new economy, because 90% of wealth creation takes place in cities, 90% of population growth will be in cities, 70% of CO2 emissions are generated in cities, and cities have the economic and the cultural clout. They don't have the political clout. The planet is becoming, we think, in large part, a network of cities. But we're interested now in how the most successful cities are becoming a network of high-functioning communities, going back to the way communities were really, 100, 200 years ago, in that they were compact, people lived and worked and played, had strong social ties. In many cases, much of what people consumed daily was produced locally, and things got completely distributed and so we're looking at this new model for communities. That's why we call this class Transformative Communities. What we're going to do is to have a series of talks, most of them by researchers that are in the city science group. We're a group of about 30 people, and they will present the ideas that we've been thinking about, been developing for many years. Your job will be to critique them and to figure out how to extend them. Okay, and I think it should be a lot of fun. So we'll do a series of exercises. You'll do some tutorials. You'll get to have some hands-on experience with some of what we're working with. I'm now going to go quickly through I call them our 10 journeys, our 10 research journeys, to give you a sense of what we've done over the years. But I want to start with this number, 2.5. So that is a really important number. So 2.5, anybody guess what that is? That'd be impossible. You have a guess?
Oh, I think it's on the screen.
Oh, there it is. Okay, so take a guess. 2.5 tons of CO2 per person per year. That is the yearly average carbon budget for every person on the planet if we're to have an 80% chance of limiting global warming to 2 degrees centigrade. So let me ask you this. What do you think this area, the Kendall Square area, generates per person per year? Anybody have a guess? 5? Way low. Anybody else? 70, way high. So we estimate 17.2. Okay, so that means we need to figure out a way, if we're going to meet these goals, of having a 7x reduction in CO2. Is that even plausible? We asked that question. So we built a model where we could look at the impact of lots of different possible interventions, the ones that we thought were the key interventions, and the whole team took a lead in this. Luis, I think maybe you'll talk about this model a little bit.
Not in my presentation, but
we'll do it later. Yeah. So we have 10 interventions. So what we did in our model is we just as a thought experiment, we cranked everyone up to 100%. We have sliders. So the first one is decarbonize the grid. Well, we cranked that up to 100%. Well, not literally 100% decarbonization. We just accepted the highly optimistic Massachusetts roadmap for decarbonizing the grid with wind and solar and others. That took us down to 16.3. Then we said, what if everyone who commuted into MIT and Kendall Square generally, because we had the data for MIT, but we extrapolated that, everyone drove an electric vehicle. So no gasoline-powered cars. That took it down to about 16. Now what you're doing is you're increasing the embodied energy, because all the embodied energy of the steel and battery and electronics in electric vehicles, and you're reducing the operational energy, so that's the net effect we calculate. Then we said, what if at any given time half the people were working remotely? I thought this would have a greater impact. That only took it down to 15.7. Then we said, let's do 100% deep retrofit of every building in the area. So new facades, insulation, new mechanicals, low energy lighting, all the things that you learn about in architecture. That took it down to about 14.5. And that number is even high because you're amortizing the savings over 100 years, even though all that carbon is going into the environment immediately. Do you understand what I mean? So what they do when they do this calculation, you calculate like what you take the possible savings and you spread that out over 100 years, or but if you actually if you actually accounted for all of the emissions that go into the air when you're producing the materials for that building and all the transportation and construction, that number would be much higher. Still, only 14.5. Live, work, harmony. So then we said, let's do something really radical. 42,000 people commute into Kendall Square every day. Let's build housing for those 42,000 people so everybody lives near where they work. That's actually had a pretty big impact, 11.2. People still need access to schools and parks and shopping and all the amenities of daily living. So then we said, let's now make all the amenities within a walkable distance. That took us down to 9. You can see these two alone are much greater than those more conventional solutions. But we didn't stop there. We said, let's do hyper-efficient housing. So this is the kind of transformable housing so you can live in half the space. So now every apartment got much smaller. That took it down to 8.5. Lightweight mobility. This is actually Naroa. She's going to talk about her project next week. But now we said, let's get rid of all the cars, and everybody, because you're moving locally, you have walkable access to most things. Everybody, when they need mechanized mobility, it's a lightweight mode. In this case, it's a autonomous bicycle that turns into a tricycle, but it could be any lightweight mode. That takes us to 8.4. Plant-based diet. Okay, that saved about a ton. Now, nobody in the whole district eats any meat. Remember, this is an extreme, extreme study. That was roughly equivalent to 100% electric vehicles. Now we're at 6.6. Then high density power. So replacing like the gas-powered generators at the cogen plant here in Kendall Square, for example, with small modular nuclear, that takes us down to about 5.9. Ultimately fusion. So you can see that these community scale interventions are much more important than those more regional interventions, but we still are not at 2.5, so maybe, we didn't model this, but maybe if we decarbonized air travel and the internet and had local manufacturing and all these other things, we could get down to 2.5. The point is that it's not easy, and what most people talk about as a solution actually is only an incremental improvement, doesn't get us anywhere near what we need to be. Does anybody have any questions about this? I went really fast. Yes, sir.
Is there any overlap between the 100% electric vehicles and the lightweight community scale mobility, like in distance savings?
Between the 100% electric vehicles?
Yeah, and like the bike.
Well, you could model this in different orders and you'd get different results. You see, so we picked this particular order because we started with the more conventional ones here. Then we went to the community interventions, and then these are the interventions outside of that. You could, you see, if it wouldn't make sense to put everybody in these lightweight autonomous modes if they live, 20 miles away and they don't have access to mass transit. They still need a car. So we brought everybody into the city, and then we introduced the lightweight modes. Yes, sir.
How does the 17.2 stack up ballpark to other cities around the globe?
Well, in the Middle East, it's much higher. I think in suburban America, it's much higher. People drive more. There's not mass transit. Those cities are roughly 20.
Yeah, we're saying 20, between 20 and 25. I mean,
Yeah. European cities are 14, 10 to 12, 14.
8. Yeah.
Yeah, so even better. They're much better. When you get to the global south, in informal settlements, they're already below the 2.5. So the way we think about it is, in the developed cities in the north, the challenge is to dramatically reduce the emissions without compromising the economic performance and quality of life, right? In the global south, the challenge is to keep the emissions below that 2.5 while dramatically improving their quality of life and economic opportunities. And that's the kind of thing we'll talk about in the session on informality.
Yeah, something that is very interesting is that the American diet, the cultural factor is very important. So the American diet is already 2.5 tons of CO2 per person. So that's why you can reduce a lot if you became vegetarian or vegan. But in other cultures, it's not the same. So that's why this model needs to be adapted depending on the place.
That's a good question. Anybody else? All right, let's keep going. So now, what's also interesting, this just looked at the environmental impact, but these tend to be the interventions that also have the greatest social and economic impact. You put housing and jobs close together, people walk more, public health goes up, people live and work in the same community, there's more exchange of ideas, the innovation potential goes up, et cetera, et cetera. All right, let me go through quickly because this is going slow. Our city science journeys. So we started mobility back, gosh, now it's been about 14 years. We did the city car project. This was started by the former dean, Bill Mitchell, who unfortunately passed away just when this was getting started. So this was a fun project. This car had robot wheels, drive motor, steering, braking, suspension in each wheel. Was drive-by-wire, it folded, you get 3 of these in a parallel parking space, front door open, you step directly out on the curb. So here are our robot wheels and the batteries, and we built a full-scale prototype, and we tested this in Vitoria, Spain. So all of those 4 innovations were embodied in this prototype, and we actually then licensed it to a company who tried to commercialize it. And they were not successful, and it wasn't surprising because when we finished this, I realized that this wasn't the future. The future was autonomy, and if you have autonomous vehicles that are shared use, you never park them in a high-value part of the city, so you didn't need to fold it. So then we worked on autonomous vehicles. This was this autonomous electric vehicle testing array, and here we were looking at headlights that would make eye contact and signal when it was safe to walk in front of you and things like that. Then I thought, well, it's still a car. We have to get lighter. So then we started working on what we called the persuasive electric vehicle. This was an early version of it. You can see these down in the lobby if you go down in the E14 lobby there. We brought in some of the interface ideas that we've been playing with earlier. Then we built a working prototype, which you can also see downstairs, where you call for this vehicle like you would an Uber. It comes to you autonomously, but then you drive it under your own control to your destination, turn it loose into the wild and back in autonomy mode, and then it goes and pre-positions to pick up the next person. Okay? And this is an even newer version that we built in our lab in Taipei. And I'm not going to show that because Noro is going to show that. So this will all be the topic of next week's session. I just give you a little teaser, okay? Now, responsive housing. This is Mies van der Rohe in the Seagram's building. Well, he built this house in Connecticut around the same time, basically as a prototype. Everybody know Mies van der Rohe? Last director of the Bauhaus in Germany, right? One of the great modernists. So we got a commission back when I was practicing architecture to build an addition to this Mies van der Rohe house. And we built this pavilion. We tried to out-Mies, and it was a lot of fun. I'm still proud of what we did, but the cool thing about it is the first time we looked at transformation, the first time I did, where this could be all glass, see these sliding doors, all screened, glass and curtains, the beds disappeared. We used Murphy beds at that time. That's the best we could do. The kitchen disappeared behind cabinetry. And then we started playing with these ideas here at MIT after I came here. This was the president's house at Unity College. And here we're looking at transformation. So here's media, living room, 2 studies. And then these turn into a bedroom. And then when they have a party, the whole place opens up. So I was really fascinated with transformation at the time. And we built this full-scale prototype. It was the first house in the US to be validated as zero energy with 1 year of user data. And then we started thinking about mass customization and how to build apartments out of modular cabinetry and furniture and the like. And then upstairs, we took that farther and we made it robotic. So this was a 200 square foot, what we call the city home. They had a queen size bed, had a fully functional office, a dining room for 6 people, a living room for 6 people, the little tiny bathroom, but that opened up and now you had a shower and a washer dryer. We had a lot of fun with that. So this was a different way of thinking if you're an architect. So rather than trying to get to the perfect floor plan, you have 6 floor plans and you can dynamically transform from one to the other. And we started thinking about how to do that in a more scalable way with prefabricated building chassis and bath pods and the like. Then we launched a company, Ori Living, and during this housing session, Asier will come in and talk about the journey of commercializing all of this technology that we developed right on the other side of the wall in a little room there when he was a graduate student. And then this is one of our apartments in New York City at Hudson Yards. We're now in 30 cities and over 100 buildings, as I recall. So it's starting to get traction. But I'm much more interested in how we can use these ideas to reinvent housing, reinvent urban housing, making it much more responsive, much more affordable, particularly for young people in high demand cities that are getting priced out of the market. How these same ideas could be used to address the challenges of aging. For example, if you're in a wheelchair, you want low counters and a wheelchair turning radius. Maybe her husband has a bad back, balance problems. He wants high counters and a narrow space. We can dynamically transform these interiors. So we'll talk about that. Food production near the point of consumption up on the 6th floor, 5th floor, I guess. We built the city farm prototype. I was really interested in facade-based urban agriculture. We found out that didn't work at all. The cost of conditioning a space to keep the plants healthy in a narrow space with lots of sunlight wasn't worth the energy that you gained from the sunlight. So these were all bad ideas. So we looked at hydroponics and aeroponics and ways of producing food near the point of consumption. This was some Photoshop hack I did of a possible restaurant we were working on. In my home, I now have 6 hydroponic systems that are running, so I continue to experiment with growing my lettuce and herbs and vegetables. This is lettuce growing over a several-day period. Lots of fun. Anyway, some aspect of this is the future. What exactly we haven't figured out yet, you guys can help us think that through. These are my tomatoes grown in my basement. Simulating space. I started working on using advanced visualization, lighting simulation back in 1998, before there were any commercial tools. We were working on a synagogue. I was fascinated by this unbuilt project of Lou Kahn. I ended up writing a book on his unbuilt work. And in the process, I really went down this rabbit hole of trying to capture what the experience, the lighting and materials and form and texture was of these great unbuilt projects of Lou Kahn that nobody had ever experienced. And now I continue to use this kind of technology, more AI generative technology, to think about a house I want to build. So these are looking at some of the options. But what we're doing now is looking at building these visualization theaters that could be accessible to lay people, where they enter into an environment and they go through a process of exploring possible futures for their urban environment, or could be their domestic environment. So that'll be the topic of one of our sessions. And these terrific people will present that work. Understanding complex human dynamics. This is the Place Lab we created 20 years ago. We opened it in 2004. It was still is, I think, the most highly instrumented living space ever built. We had hundreds of sensors. We knew where people were, what they were doing, the state of the environment, the objects they interacted with, et cetera. These are some of the little sensors that we have continued to work on. So we were one of the first people this was the year the iPhone came out, so we created these little wearables that would automatically recognize activities, and then you could see that on the phone. This is long before the Apple Watch and Fitbit or any of those technologies. We won a couple of 10-year impact awards for this kind of work at the Place Lab. We instrumented an apartment of IKEA's in Malmö, Sweden. So all these little dots are the sensors in this apartment that was a living laboratory where people would live for about 2 weeks. The bouncing ball shows the sequence of sensor activations. So this glow means whatever what sensor was on. A cabinet door was opened a lot, and where there's no glow, they were not used. So it was very useful to understand how people use space, and we're continuing to do that kind of research. We spun off a company to commercialize some of this work. This is Butler. And they're instrumenting the Microsoft campus and assisted living facilities. It's pretty interesting. So I love it when I can see this work have some impact and get out into the world. This is geolocated tweets in Kendall Square. As a proxy for human activity, we were experimenting with different ways of collecting and analyzing data to gain new insight into human behavior in the city. This is in Andorra, looking at telecom data, the movements of tourists, German people, French people, Spanish people, etc. That'll be the topic of this session on October 30th. Modeling complex human dynamics. This is Barcelona, study we did a long time ago. Even though the agent-based model at this time was much more primitive than what we're using, it sort of kind of tells the story. So you can see senior executives in red, mid-career professionals in yellow, young people in blue, and now you're moving housing projects around. So by doing that, you're moving packets of people. And it updates the agent-based model, and you can see where the people then flow to their destination. So we're continuing to do that kind of work. We're using these large language models to develop much more complex and plausible profiles of people so the agents can represent more realistic behaviors. We'll talk about that at this session. This shows how we're using some of the large language models. This is more of a demo using ChatGPT. We're doing this in a much more sophisticated way. Some of the visualizations of the movement of agents in architectural space. I'm going really quick because you're going to hear a lot more about this at this session with this team. Okay, enabling community consensus. So this is some of the work I'm most proud of. So in Boston, they were proposing a new bus rapid transit system. But there were questions about how to route the bus lines, where the stations would be, whether it would be the gold standard. How many of you know about bus rapid transit systems? You probably learned something about it. Yeah, exactly. and how to move away from these kind of contentious community engagement open mic sessions, which are just becoming very problematic. So we built a regional scale model, a community scale model, a street scale model. We put this in a community center in Dudley Square. We actually trained some of the local people in the community to lead the workshops. So the first was the regional scale. This is the community scale. You can move these little optically tagged Lego bricks around that represented stations, and all the visualizations would update, moving the station to the center for the gold standard, as opposed to on each side of the street, replacing bike lanes with parallel parking, and all the models update. So this kind of tool is really useful for community engagement. Maybe the most impactful project was in Hamburg, where we were hired to work on the 2024 Olympics. They were in the running at that time, but they were hit with this influx of what they were expecting to be 70,000 refugees from the war in Syria. So the mayor, Olaf Scholz, who's now the Chancellor of Germany, we worked with him directly to help them identify sites to build permanent housing for these refugees. So we built a very similar kind of an interface, a table where people could identify sites that they thought were suitable for housing for the refugees, using this computer vision system to zoom in to another window. They'd move these optically tagged modules around, and the models would all update, and you could see, well, if we put housing here, here's the access to jobs and mass transit and schools and the like, and then the community would decide on where to put housing for the refugees. And it turned it into a very kind of positive, constructive process rather than a negative, politically, emotionally charged process. And the interesting thing happened. These are the different districts. These people from the community were all competing with other districts to see who could accommodate the most refugees. Now, you could do the same thing with homeless shelters or housing for young professionals, or all kinds of other assets in the city. This is an article about the project, Germany's Radical Pro-Refugee Urban Planning Experiment. Okay, so we build a whole series of these interfaces. We have them around the world. We're working on different projects related to informality. This is your city, Guadalajara. So for example, this is Eva, who manages water by moving it around in buckets. She has no water supply, she has no sewage system. And we instrumented her house so we could collect data on how she actually manages water from different sources. The water she used for cooking, for cleaning, for bathing, for drinking, etc. We had a fairly sophisticated data analytics platform, but what she used was this little salamander would either be happy or sad, and that's how she monitors her water use. So this team will look at that.